In this lesson, we'll be looking at different kinds of polynomials and looking at what their degrees are. So, a monomial has one term in it, no addition or subtraction signs whatsoever in between them. It only can have one term. So an example would be 3x, another one would be 5, another one would be y to the third, another one would be 3x squared y to the fourth. Those are all monomials. They only have one term, no addition or subtraction signs. Of course, the prefix bi means two, so a binomial has two terms. That means there's one quantity and another quantity, and they will be separated by either an addition or subtraction sign. So that's how you get the two terms. The two circled things are the two terms in them. Trinomial, of course, the prefix tri means three. So there's 1, 2, 3 terms right here, separated by addition and subtraction signs, of course. Okay? Then polynomial means many terms. Actually, a monomial, binomial, trinomial are all types of polynomials. Typically, if it's bigger, it has more than 3 terms in it, we call it a polynomial. Okay? Just so you know, and you might want to write this down, polynomials, I'm going to kind of box this up so we can see this better. Polynomials cannot have negative exponents in them. Just so you know, and we will talk about why that is later in your career, but polynomials cannot have negative exponents. All right, then, there are certain types of polynomials that we want to talk about. So if it's a polynomial, it has many terms to it, 1, 2, 3, 4, 5, 6, whatever, many terms to it. There are certain types of polynomials that we want to focus on. One of them is a constant, which has a degree of 0. Basically what that means is this. There is no variable with this one, but I can think of this as x to the 0 because x to the 0 is 1 power. It's not written, but if you have no variable in it, it is a constant and has a degree of 0. A linear has a degree of 1, and what that means is the highest degree that you are going to see in any term is a degree of 1. So this is x to the 1 right here, so it has a degree of 1. A quadratic has the highest exponent you will see on your variable is a squared, or a degree of 2. So the highest exponent that I see right here is x squared. My degree is 2. If you haven't figured out, the degree is the highest exponent that you see. Okay? A cubic has a degree of 3, so that means the highest exponent that I will see is a 3, which happens to be in this term right here. Okay? It doesn't matter if I have all the other terms behind it. It's what is the highest exponent that I see. Okay? The question is this a binomial? Does it have 2 terms to it? And it sure looks like it has 2 terms to it because it's got 1 right here and 2 right here is what it looks like. But make sure before you figure out how many terms it has that you have everything, all your like terms combined if you can. And by like terms, you need to have terms that have the same base with the same exponent. So each of these terms has an x squared and a y in them. What that means is they are like terms. When I add them, I only add the numbers that are out in front. So I only add 3 plus 8, which is 11. And that makes 11 of these x squareds and y's that I have. So this is actually what I would get for my answer. And no, it's a monomial because it only has 1 term to it. Okay, so make sure you've combined all your like terms before you decide how many terms it has and what the degree would be. Then, to find the degree of each term, you add the exponents on the variables. And the degree of the polynomial will be the highest degree of any of the terms in your list. And then the leading coefficient is the number that's in front of that highest degree. And this will certainly make more sense as we go through an example here. Okay, so first of all, I want to write each expression in descending order. That means largest exponent to smallest exponent, which is sort of the mathematically polite way to write things is we typically try to write them from highest exponent to smaller exponent, okay? So I'm going to look at each term and I'm going to figure out what each term's degree is. So this term right here has a degree of 0 since I have no variable in it. So this has a degree of 0. This one right here has a degree of 2. This one, be careful, people think it has a degree of 2, but this has a 1 above it. And so really, the B has a degree of 1, the C has a degree of 2, so I have a degree of 3. Okay? And then this term right here has a 3 right here and a 1 right there, so it actually has a degree of 4. So if I were to write these in descending order, it would look like this. A, B cubed C plus 6bc squared plus 5b squared plus 12. And now my exponents are in descending order. The degree of the polynomial is the highest degree of any term. So in this case, this term right here had the highest degree. It's also written right here. That term right there has the highest degree. It has a degree of 4. So the degree of the polynomial is 4. And the leading coefficient is the number that's in front of that term. So that would be an 8 in this case. Okay? Moving on to the next one. This term right here has an exponent of 1, so it has a degree of 1. This term right here has an exponent of 2, degree of 2. This term right here does not have an exponent, so it has a degree of 0. By the way, this would be called a trinomial because it has 3 terms to it. So if I ask you what type of polynomial it is, you would call it a trinomial. And because it has 3 terms. Okay, if I write these in descending order, then I would have 9x squared minus 2x and minus 4, sorry. Okay. So the biggest exponent that I see is a 2. It has a degree of 2. The leading coefficient is the number out in front of that, which would be a 9. By the way, this is also a cubic expression, and it's a it's not cubic, it's a quadratic expression. It's a quadratic expression because it has a degree of 2. If it has a degree of 2, it's a quadratic expression, which this one does. Okay? The previous one has no special name. It has a degree of 4, but we don't worry about degrees of 4 having a special name. We only worry about constants, linear, quadratic, and cubic in this particular class. Okay? So since this has a degree of 2, it does have a special name, and it is a quadratic. Okay? The previous one had a degree of 4. It does not have a special name. Okay?